in the past module. So like some of the part transistor devices, I think I have covered the part almost all part of the part your course, and so this part's also very important for exam point of view. So I've decided to let it be for complete actually. So one thing's there in the transistor section in the first module that you can find, that is a complementary metal oxide semiconductor, because you have completed the transistor, JFET, then also MOSFET, okay. And today will be discuss actually CMOS, UJT, and other is called the SR, that is called SCR, okay. So this CMOS actually this acronym stands for the for complementary metal oxide semiconductor, okay. And this CMOS technology is one of the most popular technology in the computer chip design industry and broadly used today to form integrated circuit in numerous and varied applications. So now most of the part the devices actually based on the part CMOS technology, and all of you know there is a part VLSI, that is small scale SS VLSI, and also large scale. So MSL, that is medium large scale. So there are part different type of chip and ICs that get formed, and all these instrument, all these part actually chip and the devices are actually based on the part this technology CMOS technology. So complementary metal oxide semiconductor. So today's computer memory, CPUs, and all cell phones make use of this technology due to several key advantages. And this technology makes use of both P channel and N channel semiconductor devices, as like a part N MOSFET and also the part P MOSFET. Okay. And one of the most popular MOSFET technology that is available today is the part complementary MOS, or that is called part CMOS. Okay, technology. This is the part dominant semiconductor technology for microprocessor, microcontroller chips, memories like RAM, random access memory, then the ROM, EPROM, and application of specific indicator circuit like some ICs. Okay, so this is the part, some introductory idea about the part CMOS. Now we'll move to that's CMOS actually upon detail. So the main advantages of CMOS over the part and that is a N-type MOS, or the part bipolar technology, is a much smaller power dissipation. So that is why CMOS has the one advantages over the part a bipolar and also the part NMOS. Okay, and due to the part small power consumption and also the part dissipation. Unlike NMOS or bipolar circuit, a complementary MOS circuit has almost no static power dissipation. Okay, this is one of the part the advantages of the part the CMOS, and power is only dissipated in case the circuit actually when it is switch on. Okay, this allows integrating more CMOS gate on IC than in NMOS or bipolar technology, resulting in much better performances. Okay, so this also for another for advantage. Then complementary metal oxide semiconductor transistor consisting of part P channel MOS, that is PMOS, and also the part N channel MOS, that is called part NMOS. And if you can look to the part circuit here, so this is for the NMOS and this is for PMOS. So this is base, this is source, this is gate, this is drain, and you can see also part similarly source, gate, drain, and the part base here. Okay, so this is the part. This is for the part P. You can see. So for NMOS we have the P substrate, and for PMOS we have the part N substrate, or that is called the part N well, and this is called the part P substrate here. Okay, so this is the part the basic part. Hello, this is called the part
Yes, sir.
the yes. Hello, are you
Yes, sir.
anyone saying
Audible.
anything?
No, sir. It's audible.
Hello, is it audible now?
Yes, sir.
So this is
Audible.
Yes,
audible,
sir.
but we can't understand anything.
So tell me actually what part you are not able to understand.
So please make it clear now. What is CMOS, NMOS? Please make it clear.
Okay. So if you have joined actually the part first class actually MOSFET, okay, metal oxide semiconductor, then you may because you can just in the for
Actually, this
constructional
is my
point of
first
view.
class. So
Yes, yes, yes. Tell me.
this is my first class. So I can't understand anything what you are saying.
That is why actually it is a part. So let me tell actually just some fundamental. So complementary metal oxide semiconductor. It is actually a part, a complete or you can say actually this is a compact form of the part semiconductor device, metal and oxide. Okay, means one oxide insulator layer, one
Okay.
metal layer, and semiconductor. This is a combination of the three part. One is called metal, other is called oxide layer, other is called semiconductor. So we have started actually the class from the semiconductor. Then we have the different type of junction transistor like bipolar junction transistor, then field effect transistor. Then you are coming to the part MOSFET, and from that MOSFET,
Okay.
so advanced technology that is called the part CMOS. So which is the part actually that is complementary part metal oxide semiconductor transistor actually. Okay, so if we can go
Okay.
to the part
Okay.
the last slides of the part what I have already shared in the part group, then you can. Okay, and this is part actually
So
what
in
I
which
want to
group?
say. Yes,
In which
hello.
group you have shared all the things?
I have already in your part group, Igno group. That's I have already part share. I think you can just check your part WhatsApp. Okay.
Oh, I am not there in WhatsApp group.
You share your number in the message box, the admin will add you.
Yes, all other candidates
Okay.
which are
Okay.
actually joined.
Madam,
I think.
just a
Uh,
minute, sir. Madam, you
Hello.
will come in first day class and you will ask lot of question. Just listen what sir is telling. Don't disturb the other. Why are you not
Okay.
coming to
Okay.
Okay.
another class?
Okay. Okay.
So all the
Okay.
videos
I
are
think
Actually,
in
you
I
are
was
first
out
class.
of station.
no issue. You have recorded the class. You will upload the video. You can go through the video. You can understood. Okay. You just now listen today.
Okay. Okay. Sure. Sure.
Okay.
Okay.
Okay. So. So that's what I'm telling you actually. So this was actually the combination of the part three different part like part metal, oxide, and semiconductor, and that is now part a compact form of the part any semiconductor device. So we call it part actually basically complementary metal oxide semiconductor. Okay. So uh, 1 minute. Okay. So there are for two type of actually part this CMOS. One is called NMOS and other is called the part PMOS. So N suggests for the part N channel. So you can see N channel metal oxide semiconductor, which is part completely made up on the P type substrate. And for the PMOS, you can see this is a part N channel or N well. Okay, and you can find also part so N channel but PMOS. So only the difference is part the sub depending upon the substrate. Okay, here you can NMOS P channel P substrate and here PMOS N substrate. Okay, and here you can find P plus N, N plus N plus P plus P plus N. So this is the part basic difference between a part PMOS and part NMOS actually. So this may be a part good question for your exam. Okay, now I'm going to the part NMOS in detail actually. So you can see this is a part NMOS and this is a part PMOS. And if you can go to the part NMOS and in NMOS, that is you can source, drain, and the part gate actually. And this is the part this layer or there is a part separation between the gate. There are two straight line. One you can find actually there is a part insulation separation between the gate and that of the part base, and that separation which is called the part oxide layer or that is called IGFET means insulated gate field effect transistor, which already we have discussed in the part last classes. Okay, so NMOS is built of a P type substrate with N type source and drain diffused on it. You can see. So NMOS is built up on a P-type substrate. Already I have told you NMOS is part built up on a P-type substrate here. Okay. So this is a part P-type substrate. Okay. And with N-type source and drain diffuse on it. In NMOS, the majority of carriers are part electron, because you can see in NMOS you can find there is a N plus is part more. So as N plus is more, that means N-type semiconductors are part heavily dwarfed with the part electron. Okay, so that is why the majority charge carriers are part here electron you can find. Okay, so the majority charge carrier electrons. When a high voltage is applied to the part gate to this terminal, the NMOS will be part conduct now. Okay, similarly, when a low voltage applied to the gate, NMOS will part not operate or not conduct actually. Hence, NMOS is considered to be faster than that of the PMOS, since the carrier in NMOS are electron travel twice as fast as the part hole. You know that for this actually for this region, you know this may be caused due to the part there is very small mass of the part electron, and that is a part also small mass high speed, and that is why the electrons can move with a very high speed as compared that of the part hole actually. Okay, so now, and this is the part symbol of a part NMOS, and this is the symbol of the part PMOS, and you can see just if the part as compared to the part NMOS. So this is PMOS, a P channel MOSFET consisting of a P type source and a drain diffused on an N type substrate actually, or N type OL. The majority of the charge carriers are part here hole. Why? Because you can see there is a part P plus is part more. So as P plus is more, so naturally the holes are for the part the majority charge carrier in PMOS. Okay. Okay. Then you can find the majority carriers are per hole. When a high voltage applied to the per gate, the PMOS will not conduct actually. Okay. When a low voltage applied to the gate, the PMOS will conduct. Just reverse. NMOS will operate when high voltage applied and in not conduct when low voltage applied. But PMOS is just reverse. That means when high voltage applied, PMOS will not conduct. But when a low voltage applied, then the NMOS will be per conduct. PMOS will conduct. Okay, so the PMOS devices are more immune to noise than the part NMOS of the NMOS devices. So this is the basic difference between a part PMOS and part NMOS here. Okay. Now, I'm coming to the part working principle of the part CMOS actually. So in CMOS technology, both N-type and P-type, all of you can see, this is PMOS and this is NMOS. They are simple get interconnected. So you can see also part that is a VDD and also the part part SS here. Okay, I'll come to the part different part of the part this circuit diagram. Okay, so uh, this CMOS technology combine both the part PMOS and also the part NMOS. Like both N-type and P-type transistors are used to design the logic function. The same signal which turn on a transistor in one type is used to turn off a transistor in the part S in the other type actually. Okay, so careful listen. So as I told, P must operate with the part low voltage and N must will operate with the part high voltage. Okay, so this is the part. So in one, so for the same signal, when P must will part conduct, then N must may not be part conduct, and for the for part the N must will conduct, that P must may not be part conduct. So that means the same signal which is turn on a transistor in one type is used. It is also used to turn off a transistor of the part other type. Okay, and this characteristic allows the design of logic devices using only simple switches without need for a pool of resistor. Okay, this is the characteristic. This characteristic allow actually a part this CMOS to uh, to design a logic device using only simple switch. So you may have the part, you may find there are part one switch is there. So in on in so it can be that is called the part actually bi mode switch, or that may be part dual switch. In one condition it may be operate, in other condition may not be part operate. Okay, so that is called the dual switch also there. Okay, in CMOS logic gates, a collection of N type MOSFET is arranged in a pull down network between the output and the low voltage power supply rail actually. Okay, so this is the part the logic circuit is a has the special importance in the part in many applications due to its such advantages. Instead, the part load register of NMOS logic gate, CMOS logic gate have a collection of P-type MOSFET in all pool of network between the output and the high voltage rail. Okay, and often named as the part VDD. So you can find this about VDD, and here you can find also this is called the part pulled. This is called the part pulled. Is a pulled domain, and this is called the part network. And from here you can get the part output. This is the I0 is the part maximum. Okay, and these are the for the different part terminals through which the part different current that you can part actually current we can withdraw. Okay, so this is the basic the part CMOS working principle here. Now, if both P-type and N-type transistors have their gate connected to the same input, just like you can see, their for same input they are connected, then you can find to the same input, the P-type MOSFET will be on when the N-type MOSFET is part off, and vice versa. That means when P-type is part off, N-type is on. So the network are arranged such that one is on and other is a part off for any input pattern. Okay. So this already these things are clearly told part in PMOS and NMOS description. Okay. So this is the part working principle, circuit, and the type of the part the CMOS. Now, one question maybe part you can find, that is the latch of condition in CMOS. So you may expect the question, what is the CMOS technology? How a CMOS is get? So what is different type of CMOS? How what is the working principle? And describe and explain what do you mean by the part latch off in CMOS. Okay. So a latch off can be defined as when the short circuit occurs between the two terminals like power and the part ground, so that high current can be generated and IC can be part damaged actually. Okay, all of you can see a latch up condition is that when short circuit occurs between the two terminals like power and the part ground terminal, that is when they are part actually part connected or by means anyhow they are connected, so that is called the part short circuit condition. So high current can be generated and IC can be part damaged actually. So in CMOS latch-up is the occurrence of low impedance trail among the power rail and ground rail because of the communication between the two transistor like parasitic PNP and NPN transistor actually. So this latch-up occurs when there is a low impedance trail among the part power rail and ground rail due to the part communication between the or due to the connection between the two transmitters like parasitic PNP and NPN. Okay. So in the CMOS circuit, the two transistor like PNP and NPN is connected to two supply rail like VDD and also the part GND, means the part the so like the voltage terminal and also the part the ground terminal. Okay. So the protection of these transistors can be done through the part resistor. So if you can connect actually, or if you, so this can be avoided if you can connect a part resistor so that it can opposes the flow of the current from one terminal to other terminal. In latch-up transmission, the current will flow from VDD to GND straight through two transistors so that a short circuit can occur and extreme current will flow from VDD to that of the part ground terminal. So that is why to avoid the part latch-up condition, there must be part. There is some methods are actually methods are adapted. So one condition is part in latch-up. So if you avoid to latch-up condition or you avoid the part latch-up situation, then a high resistance can be placed in the trail to stop the flow of the current. Why the resistor there? Because if you can connect a resistor, then high resistor, then it can simply oppose the flow of the that is free flow of the current from VDD to the ground terminal. Okay, and that you can find this amplification factor will be part much less than one, much less than one actually. Okay, so again another is part the structure of the parasitic semiconductor rectifier, it will become also, so I'll discuss in semiconductors actually will be built in the part surrounding of transistors like PMOS and NMOS through an insulating oxide layer. So another is the part, so as there is a parasitic transistor like PNP and NPN is there, so to disconnect them we can also part silicon control rectifier. So that means we can also use a part control rectifier so that it not allow to the flow of the current from VDT to that of the part ground. Okay, so this technology can be, or these two method can be probably or can be very successfully but used to avoid the part latch up condition in CMOS actually. Okay, so this is so then what are the advantages of the part CMOS? So there are part you can see the main benefit of the CMOS over the part TTL means transistor logic gate are good noise margin as well as less power consumption, and this is due to the no straight conduction lane from VDT to ground, because that to avoid the latch up condition we are inserting a resistor, or we are high resistance having high resistance, or a or that we are putting a part SCR to avoid the part latch up condition. That is why the power consumption is also part less. Okay, then CMOS is used to explain the part amount of memory of the part motherboard of the computer, that now that will store in the first setting of part bijunction metal oxide bijunction integrated oxide semiconductor also bias. Okay, so these setting mainly include the part date, time, and setting of hardware TTL in a digital logic circuit where bipolar transistor work on DC pulses. Sometimes you can find also part in your computer there is a battery is used, and that is nothing your part a CMOS battery. So this CMOS battery actually part update your part system like your part date, time, and setting of the hardware component. Okay, so these are the part some advantages that you are finding in part CMOS actually. Okay, now some of the disadvantages of the CMOS also include the cost will be will be increased once the processing step increase. However, it can be also part resolved. Cost is but not no more part issue. The packing density of CMOS is low as compared to the part NMOS. Okay, MOS chips should be secured from getting static charges. Okay, by placing the lead sorted, otherwise the static charges obtained within the lead will damage the chip. Okay, another drawback of the CMOS inverter is that it utilizes two transistors. Okay, as opposed to one NMOS to build an inverter, which means that the CMOS uses more space over the chip as compared with the NMOS actually. So as already I told you, for NMOS and PMOS, they are simple opposing to each other. Okay, for a same signal, then there must be part, yes, they utilize a two transistor, and which maybe takes a part large space as compared to a part a chip. So these drawbacks are small due to progress within the part CMOS technology nowadays. So all these are disadvantages are also part overcome by making a part complementary part, or that is a compact form of the part CMOS now. Okay, so these are the part some of the disadvantages. So there are part some applications of the part CMOS, like you can find they are used in computer memories, CPUs, microprocessor design, flash memory chip designing, used to design application specific integrated circuit. Okay, these are the some of the part basic application of the part CMOS. Okay, so I think that part we have completed the part CMOS in detail. Okay, now uh, we can now go for the part that is called unijunction transistor. Okay, so what is that part unijunction transistor? Here will we go into part details. Now we'll go to the part discussion for the part unijunction transistor. Okay, so you have read the part actually bipolar junction transistor, field effect transistor. Okay, so similarly another is called the part unijunction transistor. So it is a three-terminal semiconductor device as like the part transistor. The main characteristic of the part UJT is when it is triggered actually. Triggered, the emitter current increases regeneratively until it is limited by emitted power supply. Okay, so till the part power supply limitation is not imposed, then you can find that the UJT get triggered and can operate. Okay, so it is a three terminal semiconductor device which can operate when it will be, we can give any signal to trigger. Okay, due to this characteristic feature, it is used in applications like switching pulse generator, short tooth wave generator, etc. So there are different like clipping, clapping circuits are there, flip flops are there. So where you can find UJTs are what actually used. Okay. Now I'll come to the part construction of the part UJT. Okay. So basically the UJT consists of N-type silicon semiconductor. If you can come to the part this diagram, you can see this is a part N-type substrate. Okay. Within the N-type substrate, we have a part a P channel is there. Okay. Or a P-type substrate is get dropped. Okay. And this dropping of P-type semiconductor within the part N-type substrate can form a P-N junction. Okay. So and it has three terminal. One is called the part base, or two, other is called base one, and other is called the part emitter. Not like the part collector, not like the part general transistor, a collector emitter base. It has the two base terminal, B1, B2, and an emitter here. Okay, so here you can find the terminals of these base are connections are called base terminal B1, B2. Near the base B2, a PN junction is for get formed. You can see it's a N type and it's a P, and near the base B2 you can find a PN junction is get formed between P type emitter and N type silicon bar. Okay, this is N type silicon bar and this is P type silicon bar. Okay, so the terminal of this junction is called emitter terminal, that is called part E. Since the device has three terminal and one PN junction, okay, for this region, this is called a unijunction. Okay, all of you can mark here. It is called a part unijunction transistor. So we can say it is a three terminal and one PN junction. Okay, so that's we call a PN part unijunction transistor. Okay, the device has only one PN junction, so it forms a diode actually, just like a part general diode. They also form a part general diode as only one PN junction is there and three terminals are there. Okay, so all of you careful to that actually why it is called UJT. Okay. Then the device has only one PN junction which forms a part diode. Okay, because of the two base lead are taken from one section, like you can see was the same, the two bases are basically taken from the part this N type silicon. So one from the part, so one is close to that of the part emitter, that is which is part P type P type emitter, and N type your silicon barrier. Okay. Hence, the device is also called the double base diode because there are two bases are there. So that is called the your part double base diode. The emitter is part heavily doped, while N region is part light doped. So you can see the emitter is part a P type, which is heavily doped, and N type is part light doped. Thus, the resistance between the base terminal is very high when emitter terminal is part open. That means when we are not giving any connection to the emitter, then you can find the resistance between the base terminals is very high. Okay. So this is the symbol of the part, this UJT, the two base terminals and one emitter junction, one emitter terminal here. Okay. Now how to operate? So this UJT can operate in part in two conditions. One with the open terminal, means when the emitter is open, and another condition part when emitter is actually part supplied the voltage. Okay. So when the emitter is open, then what is up? So how the UJT operate? When the voltage VBB is applied with the emitter open, you can see that means when emitter is open, we are applying a voltage across the two terminal, two base terminal, that is BB. Okay, that is called the part voltage S voltage VBB applied with emitter open. A potential gradient is established along the part N-type silicon bar. Potential gradient means that concentration of the charge carriers in one region will be more as compared that of the part other. So that is called the part potential gradient. That means in one region you can find high potential, in one region called the part low potential. So there is a potential gradient, or that is called part potential difference is there. As the emitter is located close to the part base 2, you can see here, okay, thus a major part of VBB appears between the emitter and that of the base. That means the potential gradient between the emitter and base is more as compared that of the base B1 and that of the part emitter here. So the voltage V1 between the emitter and B1 establishes a reverse bias on the PN junction, and the emitter current is cut off, but a small leakage current may flow from B2 to emitter due to minority charge carriers. Okay, I told this is the part of high potential region, this is low potential region. So naturally a leakage current may be flow from B2 to that of the part B1 here, and thus the device is said to be in part off state condition. Okay, is it clear to all of you?
Yes, sir.
Hello, hello.
Yes, sir, it's clear.
Okay,
Yes, sir.
now with emitter positive potential you can see. So in the previous diagram you have seen the no voltage applied, but here you can find when you can apply a part emitter base voltage, or that is VE. Okay, so you can see the P type is connected to positive terminal and N type is connected that of the part negative terminal, and you can see this is your part forward bias now. So when a positive voltage applied at the emitter terminal, the PN junction will remain reverse biased, okay, till the input voltage is less than that of the part V1 actually. As soon as the input voltage at emitter exceeds V1, the PN junction becomes forward biased. Okay. Under this condition, poles are supplied from P-type region into N-type bar, and these poles are repelled by positive B2 terminal and attracted towards the part B1 terminal. Okay. So this is the part, the difference that is coming actually when you can apply the part a positive voltage at the emitter. This increase in the part number of poles in the emitter to B1 region results in the decrease of resistance of this section of the bar. All of you can see. So what will happen actually? So due to this positive voltage applied, this increases the number of poles in the emitter to that of the B1 region. Why? Because it is forward biased now. Okay, and because of this the internal voltage drop from emitter B1 region is also part reduced, thus the emitter current is part also increased. So as it is get forward biased, so naturally whatever the resistance offered by the part B1 is now reduced, and now the emitter current will start to flow freely or with a high current. Okay, so as more poles are part supplied because this is forward biased, a condition of saturation is reached at the point the saturation is reached, and at the point of saturation the emitter current is emitted by the part emitter power supply. Now the device is conducting, hence it is said to be part in on state actually. Okay, so now this UJT in part in on condition. Okay, so we'll come back to the part characteristic of the UJT. So that means we have to draw the part emitter voltage and also the part current here. Okay, so the curve between the part emitter voltage VE and emitter current IE of UJT at a given value of the VVP is known as the part emitter characteristic of the part UJT. Okay, at first in the cutoff region where the emitter voltage is part increases from 0 due to magnetic charge carrier, a small current flows from B2 to emitter. This is called the part leakage current. as I've already told you, in when voltage not supplied to the part gate or gate is emitter is open, then I told the part that is small emitter current will leakage current will flow from the part B2 to B1. That is why you can find so small leakage current, and naturally you can find this start from the part leakage current means not zero current, some negative current flows. It start from the part from the base here. Okay, and above the definite value you can see, okay, VE, the emitter current start to flow again and increases the part IE value. Okay, start to flow and increases until the peak VP and IP. This is corresponding to IP value and also part VP value at point P here. Okay, after point P, an increase in part again VE, when you can find the part emitter voltage again increases, then you can find it causes a part sudden increase in the part IE with a corresponding decrease in part P. You can see after point P, a sudden increase in part IE. When the IE increases, then there is sudden decrease in the part VE. Okay, so you can find sudden increase in part IE with a corresponding decrease in part VE, and this is called the part negative resistance region. This is the part with increasing of the part current, voltage decreases. This is called the part negative resistance region. Okay, and after the point V here, our negative resistance, so that constant part maintained till a part saturation or a valley point is part often having valley point voltage VB. Okay, here you can find point VB and current also part IV. And after the valley point, the device is part driven to saturation. So after that, you can find saturation region. Okay, so this is a part description of the characteristic curve of UJT. Okay, am I clear to all?
Yes, sir.
Yes,
Okay,
sir.
okay,
Yes, sir.
okay. Now we have some advantages of UJT, like it has low cost, excellent characteristic, low power absorbing device under normal operating condition. These are, we can say, some advantage, and also there are some applications of the UJT. It can be used in oscillator circuit, trigger circuit, short to generator, bistable network, pulse and voltage sensing circuit, UJT relaxation oscillator, over voltage detector. So these are the part basic or fundamental applications of the part UJT. Okay. Now I'm coming to actually a part, a silicon control rectifier. So SCR is also part one important device in semiconductor physics actually. Okay, so all of you can see an SCR is a three terminal, three junction and four layer. All of you mark three terminal, anode, cathode, gate. Three junctions are there. 1, 2, 3, and four layer of semiconductor PN. Okay, so that is why we call three terminal, three junction, and fourth layer semiconductor device. Okay, sometimes the SCR is also called thyristor. Okay, so remember thyristor, or that is also called silicon control rectifier. So you know the part function of rectifier. We call this is called silicon control part rectifier. This is a special type of rectifier which is part is which is actually converts AC into DC, but with a some other specific features. Okay, so the SCR has three PN junction. You have seen one PN junction, two, and also three. They are part simple sandwiched. Okay, PN junction, four layer of P and N-type semiconductor joined alternatively to get PN device, PN and PN devices. These three terminals are taken, one from outer P, okay, and other from the part the outer P type called anode, This is anode. Second from the outer N type called cathode, and third from the part internal P type, that is called the part gate. And the logic symbol or the symbol of the part SCR, you can see this is gate, okay, cathode, and also the part anode. Okay. Now I'm coming to the part working of your part SCR. So how this part SCR actually part operate actually. Okay. Okay. See, so how this part SCR actually part operate. So all of you see when uh as I've already told you part this is three terminal, three junction and four layer. Okay. So and we have the part three terminal, one is anode, other is cathode, other is called the part gate actually. So what you can find, so when we can discuss this operation in part actually in two conditions. So in SCR, the load is connected in series with the part anode. All of you can see this is anode, and one load is given, that is resistance, that is RL, is connected in part in series with the part anode, and the anode is always kept positive. You can see this is also part cell, and the positive terminal is always connected to the part with the anode here, and the cathode is always connected to the part negative, means N type semi of that is negative terminal, and a gate voltage we can apply the part but the voltage across the gate and that of the part cathode. So we will first discuss in a when the no voltage is applied or that is in off condition. Okay, when no voltage applied to the part gate terminal, junction J2. You can see this is J1. If you can see here, this is junction J1, J2, and here part J3. Okay, so you can find the junction J2 is reverse biased. How you can say junction J2? This is J1 and J2. The reverse biased. How you can say? Yes. So this is a part N type and it's a P type. Okay, so N type is connected to part negative, but here you can find it is connected that of the part positive terminal. Okay, so N type is part positive, and part uh, positive means, and P type is a part simple part negative terminal. If we can consider, then you can find that is part no, or this is a part reverse bias condition here. Here you can find J2 is part reverse biased, and junction J1 and J3 are forward biased. J1 and J3 are forward biased, and J2 is a part reverse biased. Since one of the three junction is reverse biased, so there is no current can flow through the part load. Hence, the SCR is in part off condition. All of you can see that three junctions are there, J1, J2, J3, out of which J1, J3 are part simple forward biased and J2 is part reverse biased. So as the reverse bias conditions are placed between the part two junctions J1, J3, which are forward biased, so there is no current will flow through the part load, means through the part resistor. Okay, and when there is no current will flow through the part resistor, we can say it is in part off state. However, if the applied voltage is gradually increased to the part gate and the cathode, okay, then you can find a stage is reached when reverse bias junction is get breakdown. So when we can gradually increase the voltage at the gate, so naturally the reverse bias junction get formed by the part J2. It is now going on part simple more and more thinner, and and it will not opposes more charge carrier to penetrate it will allow all the charge carrier to penetrate through it, and it is get breakdown. Okay, the SCR now start conducting and becomes in on state. So the value of the applied voltage at which the reverse bias junction breaks down, okay, and the SCR becomes an on state, that is known as part breakover voltage. That is called the part breakover voltage. So I put the symbol in a uh, simple block diagram, and also I put the same symbol or same operation through a part from a rectifier symbol. Okay. Now, so when there is no voltage applied, we find the SCR operate like that. When a gate is positive with respect to the cathode, then you can find the SCR can be turned on at smaller applied voltage by the application of a small positive voltage at the gate terminal. Okay, all of you see, the SCR can be turned on at smaller applied voltage by the application of small positive voltage at the gate terminal. So you can see when you are applying a part positive voltage here, or that means cathode and that of the part this emitters get forward biased now. Okay, so what happened? So whole circuit get flow from this positive terminal, and it could be indicates the part that p type in or separate the p charge carrier in the part p type. Okay, so when the p types or the holes are part deposited at one point, at the opposite you can find there is a part negative charge is the part there. So the SCR can be turned on at a smaller applied voltage by the application of small positive voltage at the gate terminal. When gate voltage applied at the junction J3 is forward biased and junction J2 is reverse biased. Okay, thus the electron from N type layer, okay, starts moving across the junction J3 and J3 towards the P type material, and the hole from P type material will move towards the part N type. You can see. So from N type, the electrons are moving toward this one, and from the P type, the holes are moving towards support N type. So that, so this junction J3 is part now also get squeezed. Okay, due to the movement of the hole and the electron across the junction J3, the gate current starts flowing due to decrease of the width of the junction J3. Okay, because of the gate current, the anode current also part increases. The increased anode current makes the more electrons, okay, available at the junction J2. So as there is a breakover condition is here, and also the junction J2 is part get more but thin and thin due to the movement of the charge carrier, then more current will flow through the from junction J3 to the part J2. Okay, as a result of this process, in a small time, the junction J2 breaks down and the SCR is in part to turn to on condition. Okay, even if the voltage at the gate terminal is removed, okay, the SCR. So suppose I remove the part this voltage, okay, then what you can find, hmm, uh, the gate terminal is removed, the SCR and the anode current does not part decrease, and the SCR is part simple. Okay, uh, SCR simple can be only be turned off by reducing the part applied voltage to the part zero actually. Okay, so this is the part situation, or this is how the working the part SCR is part working actually. Okay, and you can see this is the part the block diagram, and this is also part that SCR with the part diode with all the part condition what I told, or what the working condition or the working process I
Sir, it's not audible.
Hello.
Hello, sir. Are you there?
Sir, you are not audible.
Hello.
Oh, hello. Yes. Yes. Am I audible now?
Yes, sir, now audible.
Okay.
Yes, sir.
Now, uh, so I'm coming to the part IV characteristic actually of this SCR. All of you can see. So this is the part IV characteristic of the part silicon control rectifier. So as I have already told you, it is a part simple PN junction. So it has the two characteristics like one forward bias characteristic and the other is the part reverse bias characteristic. Okay.
Sir, screen
The
is not
screen is
visible.
not there.
Oh, screen is not operated. Okay, okay. Let me check. Is coming.
Yes, sir, now visible.
Yes.
Now
Sir, not
visible.
visible.
Now
Hello.
visible, sir.
Is now visible.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So, so as I already told you, it is a simple PN junction. So it may operate in two conditions. One is forward bias condition, other is the reverse bias condition. So here you can find. So this is the curve between the cathode voltage V and the anode current I of the SCR at constant gate current. Okay. Now, so forward characteristic you can see when the anode is part made positive. Okay. You can see the part when the anode is part made positive here. That means we are applying the part a positive voltage to the part anode. Okay. So that you can find voltage and anode current I of the SCR at constant gate current. This is the part. This is called the part IV characteristic of the part SCR. So when the anode is made positive with respect to that of the cathode, then the curve between V and I is called the forward characteristic of the SCR. If the supply voltage is increased from 0, a point is reached, point A, the voltage is called breakover voltage, and when the SCR starts conducting, okay, under this condition, the voltage across SCR decreases suddenly, shown by the dotted line in the part curve. You can see this is the dotted line, and this is the part breakover voltage. When I told you part the junction J2 will be part breakdown, okay, it is get actually part suddenly start increase the part current, and this is and the SCR turn to the part on state here. Okay, now so if the supply voltage increased from 0, a point is reached, that is point A. Okay, the voltage called breakover voltage when the SCR starts conducting. Under this condition, the voltage across SCR decreases suddenly, shown by the dotted line in the curve also. Okay, and most of the supply voltage appears across the part load RL. Okay, so this is happens in case of your part forward characteristic, but in the reverse characteristic you can find, okay, when anode is made negative with respect to that of the cathode, the core floated between the V and I is called the part reverse characteristics. If the reverse voltage is increased gradually, you can see gradually. At first, the anode current remains small. You can see anode current part very small. That is called the part leakage current. And at the same reverse voltage, the avalanche breakdown occurs and the SCR starts conducting in the reverse direction. That is shown by the part the third quadrant here. Okay, this is the part avalanche breakdown and this is the part breakover voltage. Okay, so this is the part the IV characteristic of the part UJT. Am I clear to all?
Yes, sir.
Yes, sir.
Okay, now I'll go to the part the application or the last part of the part this discussion. So here you can find the SCR can be part used in different point. Okay, just like power switching circuit, control rectifier, AC power control circuit, speed control of DC snot motor, SCR crowbar, then computer logic circuit, timing circuit, inverter, battery changing regulator, and temperature control system, or that is the part sensing system also. Okay. So these are the part, some of the part applications of your part, the SCR here. Okay. So I think these are the good questions that you may face in a part in the exam. Okay. Am I clear to all of you? These three devices.
Yes, sir.
Yes, sir.
Okay. So I think I have completed almost all the part of your part syllabus. Okay, or the course, whatever assigned in a part in your course structure. So and I think I have already shared the part all the part of this PDF and also document to you. Hello.
Sir, sir, we do not have any materials in physics 5, okay, electronics.
Is
So
your voice
whatever
is
your
not?
material,
You are not actually
can you hear
audible.
me?
Please tell me. Hello.
Can you hear me, sir?
Hello. Tell me.
Sir,
Sir.
yes, sir.
Please.
Actually, we do not have any material in physics electronics, okay. So whatever materials that you have provided us during the classes, is that sufficient to handle the exam?
Yes. I think it is. I think it is completely.
Okay, so nice, sir. So nice, and so thank you, sir.
These
There
are
Sir,
are
please
all
share
the
today's PPT
syllabus
also.
actually whatever there I have supplied to you, and also and this course may be but helpful to all of you, or means the material may be helpful to you.
so, sir, please do post these materials to today's materials in the WhatsApp
Hello.
group, so that we can have the prints. Thank you, sir.
Please actually your voice is very low. I think not audible to me.
Actually, sir, I request you to, submit these materials in today, whatever you taught today, in the group,
Yes.
so that
Today
we
I
can
will
have
just
the
share.
prints.
Just after a few minutes I may be sharing.
So there will be no further class in physics electronics, right, sir?
I think there is no more because I completed within a part the structure class. Okay.
Sir,
Sir, it,
what kind of questions we can expect in the exam?
Uh,
Any guidance, sir?
so
sir, it,
I'll discuss with the part the coordinator of the part regional that is Paringai sir in Bhubaneswar. Okay.
Okay, okay,
Hmm.
okay, sir. Thank you, sir.
Oh, okay. So anything more that you want to
sir, it
discuss?
would be better if you could share some of the questions that may become in the exam from all the
Okay,
syllabus.
let me talk to the coordinator regional means the regional center. Okay.
Okay, sir.
Okay. Okay, let me first share all this material to you. Okay. Hello.
Okay, sir. Thank you.
Okay. Thank you to
Thank you
all.
so much, sir. Thank you.
Thank you. Thank you.
Thank you
Thank
so
you,
much.
sir. Thank you, sir.
Thank you, sir. Thank you.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Sir, is there any class today at 4 p.m.? Can anybody tell? Hello?
Yes, there is a class. Okay. In the evening for
Okay, sir. Okay.